carbon removal is going to be an essential part for making it to net zero. And there's a lot of nature-based solutions, be it in rainforests in Brazil or some of the more circular options that are emerging as well. So we have brought a couple of solutions from different parts of the world to showcase for you and to help in bringing in some spotlight on what's happening in different areas. I'll introduce the 4 speakers and solutions that we're going to look at and the sequence of the session, and then we will start one by one. So to kick us off, we have Dr. Thomas Zehetner, and I'm really sorry for the pronunciation. I'm really pronouncing it for the first time. Thomas, thank you so much for joining. So Thomas is from the WWF, and he's going to be giving us a few remarks before we start off our session. We then move on to a scene-setting presentation by Ms. Nanda Frances Bergstein, who is the CEO and founder of CAM Solutions. And then we move on to a presentation which is going to be online from Mr. Vidyut Mohan, who is the co-founder and CEO of Takashar. He's based in India, and they're doing leading work as well on bioremoval. Finally, we will have one speaker from one of our integrated parks in Indonesia, Mr. Keisuke Tanaka, who is the director of MM2100, which is an industrial park based in Indonesia. So that's going to be the solutions and presentations you're going to hear from us today. And without further ado, I'll invite actually Thomas to give us his opening remarks.
Yes, thank you. Thank you for having me. Well, after almost 2 days of discussions, I think it became clear it's not just climate change, it's everything change. The scenarios of the IPCC give us a taste of how far-reaching these changes will be if we fail to cut emissions. We have seen all the graphs, we have seen the numbers, we have seen the curves, and this is very important work, but it's also very abstract. And this is why WWF has decided to use the medium of art to raise awareness of the climate crisis. We have created an exhibition called Climate Realism that shows us the consequences of a hotter planet for people and for our nature through the eyes of great artists. So this should really give us a new perspective. And you might have seen outside of this hall, when you come up the stairs, 4 screens are showing the works of Van Gogh, Monet, Gauguin, and other artists. And it's really these artists have given us scenes whose future now is really uncertain. And yes, we do not know the future. We can only make forecasts. We can only imagine it. And that's what we did. With the help of artificial intelligence, trained on the painting style of these artists, we have adapted classic paintings to different scenarios. So we are approaching of what our future can be based on varying degrees of emission. And in each case, we look at the specific impact on a region, from the global north to the global south. And I think these visualizations also make really clear the link between the climate system and the ecosystem, showing that nature really is our best ally in overcoming the climate crisis. And allow me one final thought, as we are in this very historical ambience of the Hofburg in Vienna. I think one is reminded of the saying, everything has to change in order to stay the same. And we've heard a lot of solutions already in the last 1.5 days, also now in this panel. I think we know more or less what we have to do. So I think now it's really up to us to preserve these familiar scenes in these paintings and make sure that the landscapes of Van Gogh and Monet we can also experience for real and not just in the museum. That is climate realism. So thank you for your attention, and please enjoy our short clip, which we're going to show to you now. Thank you.
The 1.5 degrees.
We all know the numbers of global warming, but abstract numbers don't move people. That's why WWF wanted to reach them emotionally and make global warming visible in an unseen way. So we turned the numbers into a new art form. Introducing climate realism. We took 8 of the most famous landscape paintings admired for the style in which they display the beauty of nature. How would these iconic paintings look if global warming is not stopped? How would Van Gogh paint his wheat fields if extreme heat becomes the norm? How would Gauguin paint the South Sea if the sea level rises? We combined 3 of IPCC's climate scenarios with data from the regions where the landscapes had actually been painted. With a team of scientists, we fed them into custom-built AI pipelines. Trained with the styles of the artists, nearly 2,000 single frames were generated, showing what would happen to Monet's water lilies, how Tina Blau's coastline would change, and what would remain of Frederick Edwin Church's icebergs. Step by step, with each frame true to the unique style of each artist. By turning data into a new art form, people could see and feel the impact of global warming in an interactive digital experience, in a physical exhibition in Berlin, and on digital posters throughout Germany. What numbers alone could not do, climate realism achieved in a short period of time. A new kind of attention, deeper discussions, and an increased urge to act. We decide if climate realism stays an art form, or if it becomes a reality.
Thank you.
Thank you so much for that, and indeed it's very powerful to see how images are also influencing people to imagine what's happening with climate change. So I'd like now to invite Nanda to join us on stage to introduce her solution from Takashar. So please join me in applauding Nanda while she joins us on the floor.
Good afternoon, and thank you for having me in this incredibly beautiful location here in Vienna. I've already fallen in love with the city, and it's amazing to be here in a forum which brings together governments, governmental representatives, non-governmental representatives, business and academia and science, and also finance, because this is what we need when we talk about scaling global solutions. And I commend DG Dr. Gerd Müller very much for actually taking the lead on this and giving this as the title of this conference. The solution I want to talk about is something which you would probably call a carbon storage or a carbon capturing mechanism. I will gear it a little bit to the problem of plastics and microplastics, because I think that is equally interlinked with the topics we have been talking about over the past 2 days. The problem that we solve is related to something which I think is really, really close to our lives everywhere, because every year the planet is burdened with 353 million tons of conventional plastic waste. Every week, according to a study of the WWF, we ingest an equivalent of a plastic credit card. Imagine eating a credit card. And all over the world, studies have found that embryos today contain microplastics. And I don't even want to imagine what that means for future generations to build up, to grow up with this and all the toxins this also occurs, or the impact on biodiversity that has, and then again, the impact that has on climate change. There is a solution that we've developed as a company. And to be very honest, it looks like plastic. And it also feels like plastic. but it is a solution that is actually something which I would call in sync with nature. CAM is a material that can be made out of agricultural waste. If you throw it onto the ground, it just decomposes. It's fully compostable. It has no toxins. It has no internal chemicals, no microplastics. It just goes away, and it even regenerates the soil. If you throw this into the ocean, and all of you probably know about the garbage patch, if you throw this into the ocean, it just dissolves, leaving no microplastics behind. CAM can be recycled. So we've put it through the traditional recycling machines. It works. And if you put CAM as a coating on paper, you can make packaging out of it. But the CAM goes away in the paper recycling stream, and all the paper fibers can be recycled. I think what's important, and I've been in the field of sustainability for 17 years before I then turned more into the entrepreneurial direction. What is really important is that a solution, as sustainable as it is also commercially viable. And that's why we have invested a lot into an ecosystem that allows us to produce CAM in a factory in Spain at scale, 6,000 tons, where we've also industrialized the material into products that can be sold on the market and that are already being sold. As I said, we can produce 6,000 tons of CAM, but if we look at the problem, that's just kind of, I don't know, a small bit of the iceberg we're actually talking about. If we were able to scale the material that we need to implement the applications related to CAM, we could already today, with the products that we have on the market, from air pillows to stretch foam to plastic bags, replace 15 million tons of plastic waste. If you were able to scale CAM to its full potential of what it can do in packaging and different plastic applications, we would be able to cut global plastic waste by half, so 150 million tons. We're an SME, one would say, so a small business, 4 years old. Of course, this is not something we can do alone. We would be fine to just scale our material at the 6,000 tons and have a good revenue and a good profit. But we do believe that this is a solution which should go global, and which is also one of the reasons why we're here today. And this is why we're actually extending an invitation. We're at the point where we've finished our R&D, we have an own setup, we have an own factory, but we would really like to offer this solution so it can go global. We have a shareholder network that is very international already, and what we are working on now is to actually bring together global packaging companies, start looking at how we can transfer the technology via a license model. It takes access to finance to invest in infrastructure so the model can be replicated. And the great thing is the infrastructure actually exists. So it's not that we have to create new things, it exists, it just has to be scaled. And last but not least, and that's why the connection also with UNIDO is so interesting for us, access to agri-waste in order to build up more material for the solution. So this is in a nutshell what we have to offer. We are entrepreneurs. We feel that in such a model there's a lot of space for a lot of entrepreneurial spirit and also supporting other businesses to grow as we grow. We invite anyone who's interested to just get in touch with us and to help us start building and scaling the solution. Thank you for having us here.
Thank you, Nanda. That sounds like a very relevant, solution these days with the amount of waste produced everywhere, and especially agricultural waste. So your solution is, your company is based in Germany,
yes.
Right? And your plea is actually to work on opening up for supply chains in the global south. So what do you think is needed to help you in scaling up and working in these emerging markets?
So I think also just looking at, at the work which you are doing, I think it's really helping us get access to the packaging companies in different markets, help us to get access with people who have access to raw agricultural waste, so we can actually see how can we build those businesses or connect into existing businesses to build up the raw material.
Perfect, yeah. Thank you. I wonder if there's any questions from the audience to Nanda. So if you do have a question, put your hands up. There is someone in the audience who can pass on a mic. Okay, over there, please. So if we can get a mic down there. Who has the mics? No? You will need to move up here.
Maybe this one works. Yes, can you tell us a little bit about your process for manufacturing CAM, and what does the acronym CAMM stand for?
So CAMM is very simply the name of the founding members of CAM. The process is a very industrial process, actually. So we compound the material out of different compostable materials, and it gets extruded into pellets, which you saw earlier on, and then with the help of industrial packaging machines, we make film out of that. We make injection mold into rigid products. So we literally can actually take this material and work it on all types of standardized converting processes. So and I think that's the beauty of it. It kind of, you have to adjust some of the parameters a little bit, but let's see, as in a nutshell, it works quite similarly to plastics, but it's something different.
Okay, great. So thank you, Nanda, and join me once again in giving her a big applaud. And if you can just join us there, because after the next presentations, then I'll be asking you one more question. So joining us virtually now, I would like to introduce Mr. Vidyut Mohan, who is the co-founder and CEO of Takashar, joining us from India. And great, we see you here, Vidyut, so I hope that we can hear you as well. Can you try to
Yes, I can hear you well.
Perfect, we hear you very well. So the floor is yours to introduce to us what Takashar is doing and how your solution is helping in advancing nature-based solutions.
Thank you so much for having me and giving me the chance to present our solution. I'll just share my screen. Okay, so my name is Vidyut. I'm the co-founder and CEO of Takashar. And today I'm going to tell you about how we harvest value from agricultural waste, and also talk a bit about our carbon removal solution. So worldwide, close to about $120 billion per year of crop and forest residues is just burnt in the open. And in parts of the world where I live, particularly in northern India, the open burning of agricultural waste is a big contributor to the air pollution problem. And in 2021, it contributed up to 50% of the urban smog in November, actually in this part of the year. And actually, as I speak right now, the air quality, schools have actually shut down in this part of the country because of bad air quality contributed by the open burning of crop residues nearby. However, as this number suggests, this is a big missed opportunity. But we've also known for a very long time that crop and forest residues like rice straw, rice husk, sugarcane trash, coconut shells, corn cobs, etc., can be used to make a wide variety of products and energy. They have been used to make renewable energy, biofuels, fertilizers, activated chemicals, etc. But the industry hasn't really scaled up to its potential. Why is that so? The answer lies in the nature of the biomass itself. It's very loose, wet, bulky, thus making it very expensive to transport and process over long distances in very large scale and centralized facilities. So what's needed to be done is, instead of taking the biomass to the machine actually needs to go to the biomass. So at Takachar, we have designed these small-scale, low-cost portable equipment that can just latch behind tractors, trailers, shipping containers, and just can be taken to farms and forests to process loose, bulky, and wet crop residues into an upgraded, dense, carbon-rich feedstock called biochar, thereby enabling new markets and reducing logistics and processing costs by up to 75%. So this is a photo of our equipment that's operating on the field. And this was being pulled by a tractor. And as it was moving on the field, it was producing biochar from agricultural waste nearby and sequestering that biochar on farms then and there itself in a single step. This is another photo of the machine while operating in the field at one of our R&D locations on site. In terms of air pollution, our technology reduces particulate matter, volatile matter, and carbon monoxide emissions by greater than 95% as compared to the open burning of crop residues, as you can see in these illustrated comparative images. Now coming to the application of the biochar and how we are sequestering carbon. So farmers in Asia and Africa tend to pay 2 to 3 times the price of world fertilizers due to the logistics costs of importing those fertilizers, or the local governments have to heavily subsidize those fertilizers for those farmers, like in India. And fertilizer production today is highly incompatible with rural farming. It's very large scale, centralized, logistically complex, and one size fits all. And this leads to a few rural challenges: that the fertilizers are expensive, they are not customizable as per the local crop context and the soil context, and often they lead to overuse of these chemical fertilizers as well. And just as an illustrative example, in some parts of the world that we operate, such as East Africa, the Russia-Ukraine war, as well as COVID-19, actually led to doubling the price of fertilizers for farmers, which with a very thin margin proved very costly for them. So we use technology to decentralize and downsize the fertilizer production process, thereby making it feasible to implement local biochar-based carbon-negative fertilizer production in rural villages. And what does biochar do? Biochar is a great soil amendment tool. It not only helps in sequester carbon in the soil on a 1,000-year timescale, but it also increases the effectiveness of any nutrients that are mixed to it, thereby leading to increasing crop yields for those farmers, and helps us produce customized fertilizers as per the local soil conditions. We have seen till now that at the same price that farmers pay for their fertilizer inputs per season per hectare, we are able to increase their yields on average by 27% and increase their net income by up to 50% in places like Kenya and in India. So till now, our pilot has resulted in working with close to 15,000 farmers. We have created about $1 million of added rural livelihood, processed about 15,000 tons of crop and forest residue, and sequestered about 20,000 tons of CO2 emissions cumulatively. And over the long term, by sequestering this carbon-rich fertilizer blend in the soil, we have the potential to remove about 2.5 gigatons per year of CO2 emissions from the atmosphere. And by reducing open-air burning of biomass and the chemical manufacturing of fertilizers and the transportation, we are able to avoid about 5.5 gigatons per year of these CO2 emissions. And what we hope to do is connect carbon removal buyers in the voluntary market and the compliance market to the farmers who sequester these fertilizers on the soil and truly achieve climate justice, because these are the farmers that are actually impacted by the effects of climate change and environmental degradation by air pollution. And we believe our solution actually brings the value creation process truly closer to them and helps them truly achieve climate and environmental justice. Our work till now has received recognition from Breakthrough Energy, where me and my co-founders are fellows. We're also winners of the Earthshot Prize, winners of the X Prize Milestone Award, and also work with the World Food Programme in a few countries. So thank you so much for listening in, and I'd love to speak with you and chat with you on how we can get together and on moving our mission forward and scaling further. Thank you.
Wonderful. Thank you, Vidyut, so much. I love how you really brought it down to impacts to farmers. 15,000 farmers that are affected by your product. So how can we make that 100,000 farmers? What do you need? Support here. There's a global community, donors, development partners, even investors. So how can you make those 100,000 farmers in the next 2 years?
Right. So the biggest challenge we face is that currently governments are subsidizing chemical fertilizers, which are fossil-based. So we are essentially competing against, we are not in a level playing field. So firstly, we would definitely like to work together with government and private stakeholders to get a level playing field. And secondly, anyone interested on a carbon removal solution that is measurable, verifiable, and also scalable, we would love to speak with them and would love to see how we can help them meet their net zero goals, because that finance will actually help in reaching out to more and more farmers on the ground, either through offsetting or through insetting of emissions.
Perfect, thank you. I wonder if there are any questions as well from the audience. And if I may invite you to step out over here and ask your question.
Yeah, thank you very much for the interesting presentation. I'm totally convinced that biochar is an important building block of a net zero world in the future. So my question is a bit more specific. There have been processes going on the certification of biochar so that there are no harmful toxins, whatever, that you would then large scale put out on agricultural land. For example, there's the European biochar certificate, which is mandatory for application in Switzerland, for example. I was just curious whether this is a discussion, how you address it. Are there ideas to, for example, set up such standards in India or anywhere else where you're working? Thank you very much.
Thank you.
Thank you so much for the question. Yeah, thank you so much for the question. I absolutely agree. Following those standards is really, really important. At the moment, we are following those standards like the European Biochar Certificate, which are applicable worldwide. So there are standards like, there are a few standards including EBC, Pure Earth, Vera. All of those standards are applicable worldwide, and we are following those right now. And as more and more solutions come forward, these standards will also become more specific, and there'll be more standards in the future as well. The key challenge here is in the testing and verification of biochar. There are not too many labs in every country that are able to measure the specific parameters of the biochar that are required for the standards. So for example, sometimes you have to send samples all the way to Germany, which is expensive and not really scalable. So we'd love to see more local testing available in all of these countries in order to make the true quantification of this quality of biochar scalable.
Wonderful. I mean, we had an earlier discussion this week because this actually event is part of a whole week of events which included also Clean Tech Days. And there was a discussion around really the role of standards and certification. I mean, it can be a promoter and supporter for entrepreneurs, but unless there's an ecosystem that supports you to comply with that, it can actually also be a breaker. And this is particularly where the role of an organization like UNIDO can come in to support both government in setting this up, but also entrepreneurs in complying. So interesting applications, both agro-residues, but for very different purposes, from fertilizers to packaging material. That's the diversity of the solutions that we are showcasing here. I would like to now move on and invite Mr. Kaisuke Tanaka, the director of MM2100 from Indonesia, and he will present us a very, very different application in an industrial park. So join me in applauding him, and thank you for joining us.
So thank you very much. Hello, everyone. I'm Tanaka from Megalopolis Manunggal Industrial Development, which manages and operates one of an industrial estate in Indonesia. Today, I would like to share an experience of a nature-based wastewater treatment that we are using now. Okay. Yep. Look at the world map. The red pin shows Jakarta, the capital of Indonesia. Our industrial estate is located in the suburb of Jakarta. It's around 30 kilometers away. This is the map of our industrial estate. We call it MM2100 Industrial Town. It is 1,500 hectares. It has 350 companies. There are 150,000 people are working in this industrial area. As an industrial estate owner, we provide the basic infrastructures to the tenants, including clean water supply and wastewater treatment. This was our traditional wastewater treatment plant. These are large 5 to 6 meter deep open concrete reactors. In those, the treatment is taking place. These reactors are filled with microorganisms, which eat the dissolved organic matters in the wastewater. Has anybody in here visited a wastewater treatment plant like the traditional one? Yeah, just a few, not a lot of people. Yeah, there are good reasons that you didn't go. It's very smelly and it's very disgusting, honestly speaking. Yeah. So the problems that we faced back then were disgusting odor, unsightly look, not beautiful, ugly. And at the same time, we need to double the capacity because of the growth of our industrial estate. The solution was a new generation of the wastewater treatment plant, the water resource garden. We found a company, which is a Hungarian company, Organica Water, who has developed this concept and has been implementing it around the world. So what you see on this picture is what we ended up building, a water resource garden. The new plant had double the capacity and occupied only half The new plant had double the capacity and occupied only half the land. That was very important for us because we are in the business to sell the land. Yeah, the land is very important. The company who developed the solution combined 3 components: technology, nature, and architecture. They fused the 3 and came up with water resource gardens. At the heart of the solution, there are also 5 to 6 meter deep reactors. The reactors are covered, and green plants are positioned on the top. So the plant's roots can reach into the wastewater. In addition to that, the reactors also have artificial root systems. People usually think that plants treat the water, but actually, that's not the case. The role of the plants is to provide a habitat for a very diverse community of organisms. Those organisms then consume the waste in the wastewater. Because what is waste for us is a food for them. There are usually 6 reactors next to each other in these systems. As water flows from left to right, the conditions are changing in each reactor. As a result, different ecosystems develop in each tank. Because of the high diversity in the reactors, this series of complex ecosystems can be put together, and the result is more effective and economical function. The technology has many applications and the same characteristics across the board. They're significantly smaller than the traditional plant, and they use less energy. And they have this kind of beautiful botanical garden look and feel. This example is in Canada. It's a suburb of Vancouver. You can see the marina on top of the picture and the houses around the greenhouse. It's in the middle of the town. And this is what you can see from the street. It is not even called a wastewater treatment plant. It is called instead a water resource center. This example is in India. This is in the Philippines. This is another example in Indonesia. This example is in China. This is a typical interior of these facilities. Remember, what you see is the top of the reactors. Underneath, there are 5 to 6 meter deep reactors with plenty of life, consuming the waste. I think this is a wonderful example of cooperation between man and nature. It is important to note that this is a proven solution, as there are over 100 installations around the world. So, well, in summary, what did we gain from this solution? We saved a lot of land. We achieved to lower the lower energy consumption. And odor-free, beautiful, botanical garden-like appearance. This is what we gain from this solution. Thank you. Thank you for listening.
Thank you for presenting that. A very interesting solution of turning waste and wastewater into a nature conservation project. I mean, as a company, as an industrial park, what was your incentive actually to start that journey? That would be my first question.
Actually, that was back in 2015 or 2014. At that time, wastewater treatment plant was that ugly, as I already showed. And we need to double the capacity. So we are looking for the kind of advanced solutions, which is very good looking and also can expand the capacity. And then we found it, and there is no choice. Of course, we decided to purchase it. Yes.
Perfect. So turning an industrial problem into a nature-based solution. Wonderful. Any questions for Mr. Tezuka? Any questions from the audience?
Thank you very much for this innovative work. I would like to know a series of reactors. I'm Dr. N.P. Singh from India. Series of reactors. What is the retention time of the effluent, which goes from one bioreactor to other? Retention time.
Oh, that's a very difficult question for me, actually. I'm from an industrial estate owner, so I'm not a technical person. I'm sorry about that. Please ask the organic. I'm sorry about that. Yes.
Okay. Well, I mean, I guess you can connect and help him find the answer later. So thank you so much. I'll just invite you to sit over here just for a final reflection question from Nanda, from yourself, as well as Vidyut, who's joining us online. So what is one thing that you would like to ask this global community to help actually in advancing some of these nature-based solutions and helping drive more financing towards nature-based solutions? So in a quick 1-minute round, maybe if each of you can tell us, starting with you, Nanda, what is the one thing you'd like to ask from the global community?
What I'd like to ask from the global community is that we are able to sit down with large financial institutions, with government representatives who are interested in really working on the waste topic in their countries, and also companies from those countries with packaging, that we actually can sit together, look at the business case, and see how we can scale that model. We have all the numbers, and we also have the infrastructure and the technical details.
Perfect. Let's move to you, Vidyut, online. So what is your one ask from the global community?
So I would like to reach out to corporate. I would like to reach out to corporations and try to see if we can explore a way to work together to help them achieve the net zero goals in terms of either offsetting emissions in a measurable and transparent way, or even insetting emissions. So if there is a food company, for example, our solution directly fits in their value chain, and we are able to, our solution would be able to actually bring about that carbon sequestration on the farms of their supply chain itself. So that's something that we would definitely be interested to explore in. And since our solution has all this data acquisition, we are easily able to translate how much carbon we are able to sequester, measure that, and report that in a very transparent manner. So yes, we would definitely like to work with corporations and we help them meet the net zero goals.
Very good. I mean, I think we need to achieve scale, and obviously that's something that could help your company, but I can easily think of perhaps a platform that can be supported by organizations here, including UNIDO, to actually help in connecting also investors and corporations to some of the startups that we see with us today. What about yourself? So what would you like to ask?
Can you repeat the question again?
So the question is, what would be your ask for the global community to bring more financing to support innovations like what you've implemented?
Okay, in my opinion, first of all the stakeholders needs to be educated and informed of these kind of solutions. So I think we would like to request all the stakeholders to drop by Indonesia and to see our facilities, and you can feel how the nature-based solutions is working. And then if it's good, and there is no reason that we don't foresee this kind of solutions, I think, yes.
Perfect. So a study tour to your facility and many others sounds like a very good idea. So please join me in thanking all of our 3 speakers.